Hey guys, so today we're going to go over a couple of parent function graphs. So parent function graphs are when you have no numbers being added, subtracted, multiplied, divided to it. So it's just something like x to the second power. So a parent graph is very important because if there's a transformation meaning numbers being added, subtracted, multiplied, or divided to it, you will be able to use your parent function to actually graph that. So I just want to note a couple things for this parent function, x to the second power. Notice that some points are 0, 0, 1, 1, negative 1, 1. And those will never change for x squared. And if you ever forget them, it's fine. Just make an xy table. Negative 1, 0, 1. Plug it in. Negative 1 squared would be 1. If x is 0, 0 squared is 0. And if x is 1, 1 squared is 1. So those are the same 3 points right there from the parent graph. So no need to memorize. Um, Same thing here for the cubic function. Notice some key points here is negative 1, negative 1, 0, 0, 1, 1. And again, if you ever forget it, that's fine. Just create those same 3 points for an xy table and plug it in. Negative 1 to the third power is negative 1 times negative 1 times negative 1, which is just negative 1. 0 to the third power is 0. And 1 to the third power, meaning 1 times 1 times 1, is just 1. So you always have those to fall back on, your parent graphs. And this works for any type of graph. Square roots, linear, they all have parent graphs. Numbers not being added, subtracted, multiplied, divided by it. And they're going to be your foundation. So I'm working with these two today. So to see what an even function is, there's two ways to see even and odd functions. One is from a graphing approach, and the other is from an algebra approach. So if I were to do it graphically, just keep in mind that any even function is symmetric with respect to the y-axis, meaning the y acts like a mirror. So a quadratic, meaning x to the second power, is going to be even because if I graph it, it's a parabola. And if I make a line right across the y-axis, one side looks just like the other side. So it's like a mirror. And algebraically, to determine if it's an even function, I'm going to replace the x with negative x. And if it comes out exactly the same as it began with, it's an even function. So notice if I replace x with negative x, and I'm using x squared. So I replace the x squared with negative x squared. What happens when I square a negative is that it becomes positive again. So it's just x squared. It's the same thing as it was before. So two ways to tell if it's an even function. Graphically, when you graph it, one side of the y-axis looks just like the other. And algebraically, if you replace the x with negative x, it'll come out exactly the same as it began with. So quadratic is an even function. Now, an odd function is symmetric with respect to the origin. So that means that quadrant 1 will look just like quadrant 3. And I know this isn't the case, but if you were to ever graph and quadrant 2 looks like quadrant 4, that's also symmetric with respect to the origin. So one side looks directly like the other diagonally. Now, algebraically, you're still going to replace the x with negative x. The only difference is if it's an odd function, every single term is going to come out the opposite operation. So if it was positive originally, it's going to be negative. If it was negative originally, it's going to be positive. So if I were to replace the x with negative x in a cubic function, remember negative x to the third power means negative x times negative x times negative x. So if I were to multiply that, that would give me negative x to the third power. A little shortcut to that, anytime you have an odd exponent, it stays negative. Anytime you have an even exponent, it becomes positive. Now, keep that in mind with the parent graph, 0, 0, negative 1, 1, 1, 1. Keep keep those parent function points in mind when you're dealing with transformations of the graphs as well. So I want you to look here, oppo-samo. It's not really anything that's taught in a math book, but it's just kind of like a mnemonic device to help you remember. If a number is being subtracted inside the parentheses, what you do is you go left and right, but you do the opposite. So oppo. And then samo, if a number is being added or subtracted outside the parentheses, you move those points up and down, meaning you do exactly as it says. So let me show you an example. So x minus 3 squared plus 1. So let's just say I were to ignore the minus and the plus signs and the numbers it's being added and subtracted to, and my parent function would be x to the second power. So these are my parent function points right here, the one in blue, 0, 0, negative 1, 1, 1, 1. So what does this mean? Well, anything that's being added or subtracted inside of the parentheses, remember oppo-samo, you moved to the left or the right, but you do the opposite. Negative 3, you would think you go to the left 3, but you do the opposite. So you're actually moving right 3. And the plus 1 that's being added outside of the parentheses means you shift those points up or down, but you do exactly as it says, so samo. So since it's plus 1, that means I'm moving up 1. But right 3 and up 1 from what? From the parent graph. So these 3 points in blue, what I'm going to do is I'm going to move them to the right 3. So 1, 2, 3, up 1. This next one, I'm also going to move to the right 3. 1, 2, 3, up 1. And this one as well. 1, 2, 3, up 1. And there's my new parabola. That's my new graph. Same thing with g of x. So if I were to just take away all the numbers being added and subtracted, I would just have x to the third power. So this is my parent function. These are the points I'm working with, the parent function points. So in order to know what this graph looks like, I'm going to do oppo-samo. So plus 2 is being added inside of the parentheses. Remember, if it's inside, you move to the left or right, but do the opposite. So since it's plus 2, you would think, you're headed towards the right, but you're doing the opposite, left 2. And then there's a minus 2 outside of the parentheses. So if it's being added outside of the parentheses, you do exactly as it says, but you're going up and down. So you're going to go down 2. So from here, left 2 and down 2 from what? From these points given in the parent function. So what I'm going to do here is I'm going to go left 2, down 2. From here, left 2, down 2. And this point, left 2, down 2. And this is my graph. Same shape, same, nothing changes with the shape. It's just shifting, it's moving left, right, up, or down. All right, guys, hope this helps.